Hi guys, so it's looking like I'm gonna have to do two things at one time. I took a little break from recording because I had some personal things going on and I didn't realize how many people were really looking for the videos. So I'm glad you guys are watching. So I was like, okay, I gotta record regardless of what's going on or how I look or whatever. I need to get these videos out. So while I'm getting my morning workout on, this video is going to be about asymptotes. So there are three different types of asymptotes. There is vertical asymptotes, horizontal, side to side, vertical is up and down, and then there's oblique. Oblique is just a diagonal line, and it can have any type of y equals mx plus b type formula, and that's called an oblique asymptote.
Okay, asymptotes. You have three different types, as I explained before: vertical, horizontal, oblique. And I just wanted to draw a visual of what they look like. I mentioned before that it's kind of like an imaginary line. So if you had an XY plane, and let's say I'm drawing a vertical asymptote, I'm going to make this line dotted. The reason why I'm making it dotted is because it's not really there. It's just helping me guide my graph. That vertical asymptote will have some equation attached to it, like x equals c. Any vertical line is x equals something. And then your graph will just get extremely close to it. It just never touches this vertical line. It could go up like this or down like this. But the equation for that vertical line is always going to be x equals something. And that could be any number. A horizontal asymptote is the same way. So if you had an XY plane, horizontal asymptote, it would again be an imaginary line, so I'm going to make it dotted. The equation that goes for a horizontal line is always y equals something. Y equals something. And your graph gets extremely close, it's just not going to touch that line. And again, the equation for that line is going to be y equals something. This is going to help you guide your graph. I'll just say y equals L here, but y can be equal to any number, so I'll just put y equals something. The last type of asymptote is oblique. So if it's not horizontal, if it's not vertical, it's just going to go like diagonal. I'll just draw a diagonal line like this. It's again going to be dotted. And your graph will get extremely close to this line and just won't touch. So your graph could look something like this or something like this. It's just going to get extremely close, just not touch. Now, diagonal lines, we know from previous math classes that that's equal to y equals mx plus b. So anything that's set up in that form y equals mx plus b is going to be an oblique asymptote.
So I'm going to start this video by talking about vertical asymptotes, the procedure to find a vertical asymptote on a rational function.
So here we have vertical asymptotes, and the first example we look at, what you want to do for the first step is make sure that the rational expression is reduced. And the way you do that is you factor the top, you factor the bottom, and see if there's any like terms that can be crossed out. With this first example, it's completely factored at the top and the bottom already, and nothing will cross out. So for step number 2, what we want to do is set our denominator equal to 0. So on this example, since it's already reduced, I take the denominator x plus 4, set it equal to 0, and I solve for x. And step 3, the value that you found from the denominator, that is your answer. So x is equal to -4. So for this particular graph, it's going to be a vertical asymptote at x equals -4. Let's look at the second example. So step 1, we want to factor the top, factor the bottom to see if it can be reduced. We want to reduce our rational expression. At the top, if I factor, I get x plus 2, x minus 2. But unfortunately at the bottom I can't factor that. This is not the difference of two squares because there's a plus sign in between there, so I can't factor it. So it is already completely reduced. Now step number 2 is to set my denominator equal to 0. And I do that and I can't factor it. If I do try to solve for x, I would subtract the 16. I get x squared is equal to negative 16. And if I take the square root of both sides, I end up getting plus or minus 4i, which is an imaginary number. We can't do anything with that. So for this particular example, because there was no real values of x from the denominator, there are no vertical asymptotes. Now let's look at a third example. I have x squared plus 6x plus 5. And in the denominator, I have 2x squared plus 7x plus 5. Now, step 1, reduce the rational expression. So let me factor the top, which I will get x plus 5 and x plus 1. And in the denominator, if I factor, I get 2x plus 5 and x plus 1 again. If you have problems with factoring, I will put the link in the description box on how to factor this using the AC method. Notice the x plus 1 is at the top and the bottom, so that can be crossed out. And when I rewrite this rational expression, this is completely reduced. So now I set my denominator equal to 0. 2x plus 5 is equal to 0. And then I solve for x by subtracting the 5. And then I divide by 2. And so my vertical asymptote is going to be x is equal to negative 5 over 2. One more example I want to look at. Let's look at 8x squared plus 23x minus 7 all over 4x minus 1. So let's see if we can reduce. The first step is to reduce. And if I factor, at the top I get 4x minus 1 and 2x plus 7. Again, if you can't factor, there's a video in the description box to tell you exactly how to factor. At the bottom, it's already reduced. And then the 4x minus 1, they cancel out. So all I have is a numerator. So I have no denominator. Therefore, there's no vertical asymptotes for this problem.
Okay, now that that's out of the way, let's talk about horizontal and oblique. Now, I put these two together because the steps are the same. The result of the steps will tell you whether you have a horizontal or oblique. So now I want to do some examples of how to find horizontal and oblique with a rational function.
Okay, horizontal and oblique asymptotes. I have the first example on the paper. And your first step, we need to know whether this rational expression is proper or improper. So if you think about proper versus improper fractions is where the numerator is greater than or equal to the denominator. So like 5 over 4 is an improper fraction. 3 over 2 is an improper fraction. 3 over 3 is also an improper fraction. Versus a proper fraction will be like 1/3, 1/2, 2 over 3, where the numerator is smaller than the denominator. So according to proper versus improper, what we're going to look at is the degree of the numerator and the degree of the denominator. So the degree at the top is 1 because the exponent is 1. And then the degree on the bottom, the highest degree is 1 because the exponent is 1 on the x. So this is considered to be an improper rational expression. Now, if you have an improper rational expression, what we need to do is long division. So if you determine that your rational expression is improper, you're going to do long division, where the polynomial at the top will go inside the house, the polynomial at the bottom will go on the outside, and then you have to do your long division with the rational expression. The video for long division is in the description box. So if you want to see step by step on how to do long division, you could look at that video on how to do that. So for this particular problem, when I do the long division, I end up getting that my answer is 3. If you look at the top, your quotient is going to be 3. And that is going to be your asymptote. You say y is equal to 3. Now, because I didn't have any variables in my answer, it's considered to be a horizontal asymptote. Y equals 3. Let's look at another example. Let's look at 4x squared over x to the third minus 1. So the degree at the top is 2. The degree at the bottom is 3. So 2 over 3, that is a proper fraction. So if you have a proper fraction, there's no work involved. You just say y is equal to 0, and that's a horizontal asymptote. Whenever you have a proper rational expression, no work is needed. You just say y is equal to 0, horizontal asymptote. So yay to no work. Let's look at a third example. Let's look at 8x squared plus 26x minus 7 over 4x minus 1. Now, if I look at the degree at the top, it's 2. The highest degree at the bottom is 1. 2 over 1 is an improper, so this is improper rational expression, which means we need to do some work. Let's do our long division. The polynomial at the top goes inside the house. Polynomial at the bottom goes on the outside. And I'm going to look at my first term. And what I need to multiply the first term by is 2x in order to get the first term underneath the house. Again, the step-by-step way to do long division is in the description box if you need to see long division done step by step. So I change the signs here and I bring down 28x, bring down the 7x, and I start the process over. I need to multiply 4x by 7 to get 28x. I change the signs here. And now that my long division is complete, I have at the top my asymptote, and it's going to be y is equal to 2x plus 7. Now this is considered to be an oblique asymptote because it has an x in it. It's set up in that y equals mx plus b form. It's not just a number. Let's look at one more example. Let's look at x squared minus 4 over x plus 5. Now the degree at the top is 2, the degree at the bottom is 1, and 2 over 1 is improper, which means work needs to be done. So at first I put x squared minus 4 inside the house and x plus 5 on the outside. But we have a problem here. There's gaps. I can't have any gaps inside the house, and I go into greater detail with that in the long division video, so you may want to check that out. But let's cross this out and fill in the gaps because I don't want any gaps as far as my degrees go. So I have x squared. There's no x, so I put 0x. minus 4. Now I can do my long division. I have to multiply this by x. Change the signs here. Then I bring down the negative 4. And I have to multiply the x by negative 5 to get negative 5x. And I end up getting a remainder. After I change the signs, I get a remainder of 21. Which the remainder doesn't matter. I just really need the quotient at the top. So this is what I'm looking for. So my answer is y equals x minus 5. Which is again an oblique because it has an x in it.
Okay, I'm almost to my house. So, hope you guys have a good day, and I'll see you in class, maybe, if you're in my classes. Maybe watching the videos and not in my class, which is fine.